This is Gopalakrishnan from NCHD, sir. Let's wait for another 3 to 5 minutes, sir.
Oh, okay, sir.
Good afternoon. Greetings on this Ram Navami occasion to all.
Sir, good afternoon.
Good afternoon, sir.
Good afternoon,
Good
sir.
afternoon.
So, good afternoon to all.
Yeah, good afternoon, sir. Please start.
Let's start the session.
Sir.
Let's... Good afternoon to all.
Start, sir.
Yes, sir. Good afternoon to all participants.
Good afternoon.
Yes. Esteemed speakers.
Good afternoon, sir.
Good afternoon. Speaker, esteemed speaker, and respected members of the Institute of Indian Foundrymen. On behalf of IAF Southern Region, IAF Bangalore Chapter, and National Center for Skill Development, it is my privilege to extend a warm welcome to each one of you on this insightful webinar on implementation of agentic AI in Foundry operation. We are delighted to see enthusiastic participation from industry professionals who are keen to explore emerging technologies that is shaping the future of manufacturing. The rapid evolution of artificial intelligence, particularly agentic AI, is transforming operational efficiency, efficient decision making, and innovation across industries, including the foundry sector. Today's session aims to provide valuable insight into how agentic AI can effectively be introduced and implemented within in foundry operation to enhance productivity, reduce defect, and drive smart manufacturing practices. We are honored to have our distinguished speaker, Mr. Abijit Bhattacharya and Mr. Aditya Bhattacharya, who brings with them extensive knowledge and practice experience in this domain. We are confident that this section will both informative and inspiring. I would also like to acknowledge the organizing teams for bringing together these important initiatives that align with our vision of continuous learning and skill development. I encourage all participants to actively engage during the session, share your perspective, and make the most of these opportunities. With this, once again, I welcome you all and wish you a highly productive and enriching webinar. Now, the trainer introduction will be given by Mr. Padmanabha, sir.
Thank you, sir. Sir Abijit Bhattacharya, I know him very well from many years. He's a B metallurgical engineering from NIT, and he's having 38 years of extensive experience in foundries like Kirloskar, Hitachi Metals, BFW, Dakshin Foundry, Sigma Electric, Rapsri Engineering, etc. And he was handling cast iron, ductile iron, copper, and brass castings. He's having extensive knowledge of casting business and processes, effect analysis, process optimization, and foundry operations, also greenfield projects. I welcome Mr. Abijit Bhattacharya for this session. And
Thank you, Padmanabha.
And we have another speaker, Mr. Aditya Bhattacharya. He is having MS from UTD, Texas, USA. He did MBA from Chicago Booth School of Business, USA. He is having extensive experience in implementing agentic AI manufacturing companies, and he bridges the manufacturing domain knowledge with AI deployment. Welcome, Mr. Aditya Bhattacharya, for this session. Thank you.
Thank you.
So, please continue. The session is yours.
Thank you, Padmanabha. I will just share the file. Meanwhile, I welcome everybody and I encourage you to ask any questions. What we will do is we will share the slide first. Are you all able to see the slide?
Yes, sir. Yes, sir. We are able to see.
So the topic what we are talking about is application of or implementation of agentic AI in foundry operations. What we have done is we have divided the session into two parts. First thing is we'll give a very small description about what is agentic AI and then how it can be implemented in foundry. I will also give some examples how it has been implemented everywhere in many of the foundries, mostly outside India. and how it presents a uh, opportunity for us, for all of us as active Foundrymen to improve our productivity. I will ask Aditya to handle the next slide.
Sure. Thank you for having me this afternoon. Happy to share my knowledge and background here. So there's been a very seismic change in terms of how technology has progressed over the past 2-3 years. So we all very commonly know that ChatGPT is very commonly used for a lot of daily tasks. A lot of people are using it to have normal conversations with the chatbot and asking it all kind of questions. But the capabilities of AI does not just stop there. AI is capable of now doing very complex actions and also do those actions autonomously without any user intervention, something that was not possible before. So just to give a little bit of background, historically in the manufacturing space, there's tools that were used that were called robotic process automations, RPA. So RPA were very commonly done to do any kind of document processing and email processing or any kind of small tasks where you have some input file coming in and then processing and outputting it. But there was a lot of human involvement required there as well, because what used to happen is that somebody had to sit down and build those workflows. So there were these tools like Automation Anywhere and UiPath, and more such tools have been used in the manufacturing space. And somebody had to sit down and create those workflows where they would have to very manually decide what action had to be taken and how it had to be taken, and they had to manage all the fields and all the things that were part of those. So that's where agentic AI comes in, because agentic AI is something that can very easily and very well understand the relational data. So, for example, if you have, let's say, if you take planning, for example, so there are a lot of different parts, and then you have how to plan those parts and in which order, and what should go first and what should go later. So all of this relational data earlier had to be done manually. And now with agentic AI, a lot of that can be automated because the AI understands about what a high priority item means, what a low priority means. So it understands all the basic information behind that. So what it can do is it can perceive. So it is collecting a lot of data. Then it can reason about how that data relates to one another. So, for example, like it's mentioned on the slide, so if you have data from sensors or machines or your ERP system, whatever system is that is generating this data, it can take all of that and understand how it relates to one another. Then it can decide what to do. So if you have some kind of an action you want to take, if you want to specify that, take all of this data, tell me what happened in the last 1 month or what happened in the last 1 day, and it can take all of that data and understand and generate trends from it. It can generate a lot of insights from it about how your system has been performing over time, how it has performed in the last few days, what has changed. And then it does not just stop there. The next action it can take, it can actually give you something prescriptive. Okay, you know what? So this machine specifically has been underperforming, and that seems to be the bottleneck. So if you were to increase the efficiency of this process, your output also will directly increase with that. So these are the kind of things that agentic AI is able to do right now. So instead of following any fixed instructions or prescribed instructions, it can take the data on the fly and then generate new insights every time, depending on how this system is changing or how the data is evolving. Can we go to the next slide? So this is something we put in the presentation because, as you can see on the, I would say, northwest corner of this slide, there's production between transportation and installation and repair. And you can see that the blue mark is about how much AI has made inroads into production. And the red is basically how much it is currently in state. So the blue is the potential and the red is how much it has currently penetrated the production environment. So it's almost negligible. It's hardly done anything. So this is where the opportunity is right now, because agentic AI is eventually going to come into production and manufacturing. And the thing it is going to do is exactly that I was mentioning earlier. It is going to take all of this data, all your chemistry data, sensor data, all your logs, all your machining details, everything, and can take all of that and it can give something completely new that, something that we might have overlooked or something we might have noticed before. So the opportunity is huge right now in terms of how much adoption uh, there potentially is in this domain. Next slide, please. So far, this is how it has evolved. AI has evolved. So earlier, the basic AI machine learning, it could take any kind of data and you had to again, manually say what outcome you wanted, and it would tell you what has happened. So it could only look back on the information and tell you what has happened. So that's when all the reporting and everything could be generated by AI. And then about 3-4 years ago, when ChatGPT came into the picture, that's when all the new models that are actually trained on a large corpus of data started now analyzing the data and giving a more deeper insight about not having just very static kind of dashboards, but looking at those dashboards and then determining what the insights could be. Then what will happen? So if it used to then tell, okay, if you continue on this path, this is what it would look like. So if you have, let's say, your cash flow statements. So given all the previous cash flow statements, if you continued on the same path, this is what the future would look like. This is how you will land. This is how much you'll generate in the next few months. Now, the next thing is you can say, okay, you know what, you can give it a goal. So agentic AI is very good in chasing a goal. So you want to say, my turnover is this much by this time of the year. I want to make sure that I reach a golden standard. So I'm just taking this as an example that maybe in the first 9 months of the year, you have done about 50-60 crores of turnover and you want to add another additional 40 to it. So your goal is that by the end of next quarter, you want to reach 100 crores of turnover. Now that gap, how do you bridge that gap? So we may find, many different ways of doing it, but as humans, we are also restricted by how much we can actually predict what would happen. And if we were to change certain scenarios, if we were to change, which product we should produce more, which has the best margins, and can we prioritize those? Where are our customers? Can we reach out to more customers? Who are our main competitors? What are they doing better than us? So these are all the kind of things it can take as input. And when you say, okay, tell me what do I need to do? If I was to, am I audible?
Yeah, you're audible. Continue.
Yeah.
Okay, cool. Yeah, sorry, I saw a message there. Maybe. Yeah, so you take all of these inputs and you give it a goal that, what, help me reach this 100 crore turnover by the end of the year. It will take all of your data and it will tell you what things you need to do in order to reach that goal. And that is, the true power of your agentic AI. Give it a goal, tell it I want this to happen, and it will tell you ways you can make it happen. Next slide, please. So this is again a little bit of what I alluded to earlier. So the traditional rule-based systems followed a pre-programmed rule. They could only handle very specific tasks. You had to train it for that specific task, and it could only do that. It could not, extrapolate into anything else. Humans needed to interpret the results and what they do. And any unexpected situation or something came up, the system would just break down. It could not handle that itself. And there was only a single source of all of this data. Now, Agentic AI, it can create goals, sub-goals. It can take autonomous action. It can decide and what kind of information. In fact, the power of Agentic AI is that it can ask you questions. So if you can try this yourself, you can go to ChatGPT, give it some scenario, right? Like let's say marketing has given you some target and it seems you may not be able to reach it or you are able to reach it. And then ask it questions about, what am I missing here? Something like that, right? And and with the information that I've given you, can you tell me more and what do you need? What kind of information do you need from me so that you can make a better decision? And it will actually tell you. that, have you done this? Have you done this? Have you tried this? Have you tried something else? So basis, yes or no questions or something, you can actually have a very fruitful conversation with it where, it's also giving you information or giving you different ways of looking at a problem that you might not have thought about before. Next one, please. Yeah, so I'll turn over the presentation again back to Abhijit, sir.
Yeah, so we had a difference between what ChatGPT can do and what agentic AI can do. Now, when we talk about agentic AI, it learns, it perceives, and then it advises, and then it compares our actions which we had taken earlier. Now, when we talk about Foundry, there are so many areas where agentic AI can be implemented. So these are the certain areas where we have started working, like predictive quality control, energy optimization, predictive maintenance, production scheduling, supply chain intelligence, and safety and compliance. The normal, when we talk about a Foundry supervisor, we all know that once a new person joins a Foundry, he spends a lot of time in understanding the operations. Then he will take a lot of time to learn. Then he will take a lot of time to assimilate the data and take a decision based on that data. And that action, whether it is consistent or not consistent, that also it is very difficult to judge. There is a saying in Foundry that the first 2-3 years, we do not know what's happening. Then we start gradually to learn. All the old Foundrymen will be knowing that how much time it takes for the Foundry person to pick up. And still we have a debate, whether it is a science or an art. So these actions, these areas, we have already started seeing how the AI can be implemented. And all these points are very, very critical because it is affecting cost, it is affecting delivery, it is affecting rejections. So the action is to take help of agentic AI and try to see where best we can increase our productivity. Now, we have various kinds of foundries, and every alloy has got its own peculiarities. And most of the people, they develop their expertise in a particular area. For example, gray and ductile iron, if the people who have been working there for a long time, they will be having a certain kind of knowledge which will be different from a person who is handling aluminum or who is handling brass or copper. So when we apply agentic AI, let us say in ductile iron, and we tell it to monitor, for example, here we are saying that monitor the carbon equivalent or the inoculation time. And then what it does is that it keeps on monitoring and then keeps also monitoring what are the properties, what are the rejections like. So when we do the implementation, that Foundry as a whole, it gets interlinked. Then, for example, based on the chemistry, predict the nodularity. Then are there any data which may lead to shrinkage issues? Then one big thing which Foundrymen will be able to appreciate is that everybody has a different perception about a given microstructure. So analyzing microstructures is one of the areas. Then identifying acceptable defects and not acceptable defects. So the address is based on the consistency of application of the knowledge. Then similarly with aluminum, similarly with brass, the rejections are very expensive. Brass is an expensive alloy. So what we are trying to see is what best solutions can I get from an agentic AI so that my defects are less, my delivery time is on time, I am able to get maximum of the capacity available with me. And in Foundry, you know that any capacity which is already lost and gone, it cannot be recovered. So how to do that? So in the coming slides, I will explain some of these specific areas. This we are talking about casting, design, gating, and risering. Now, this is one of the areas where there is a big pressure on the foundries to design a casting. And most of the components, customers give us some component. And based on the production line we have, every foundry has got its own casting design principles. There are certain guidelines which are already known, which is there in the literature, but all that information is tweaked to suit our requirements, to suit our facility. So when we do the casting design, it can tell us that, for example, if I am making, let us say, a turbine housing casting, and I have a family of turbine housing castings. So when I design the first one and I use the same tool to make the second one or the third one, whatever knowledge we gathered or the AI gathered in the first or second or third, it correlates with the result and then itself it designs. So the casting design, the 3D CAD models, all this can be done. And we have experience that, for example, a designer who makes a casting drawing, if he takes about 7 to 8 days to make a complex drawing, AI, if we feed him the logic or inform him the standards, it can do the whole thing in less than 5 minutes. So designer productivity, we have established that there is a multifold jump in that. There are gating and risering solutions also. Once we explain what are the facilities we have, what are the complexities we have, so the AI module, it keeps on learning. We can consider this AI tool or agentic tool as a new supervisor who keeps on learning. The benefit of this is that it does not forget. And once it has accumulated the way we work, the way we design the casting, it remembers, replicates, and then suggests. So this is one of the areas which data is informed to us well in time. Then calculates ideal riser size, position, quantity, real-time processes, connecting it to a defect. See, all the trials which we take on the foundry shop floor, let us say we have made a new pattern which needs to be taken into production, and we see how it comes like. So there is a rule which says we post 4 or 5 castings, then we post 10 castings, 20 castings, and then normally we link how much the rejects we get and whether the quality results are okay or not. And once we keep on doing this and we do the tweaking and all this is remembered by the tool. And then it intelligently applies to the section. Then there are certain castings which are, for example, which are prone. For example, if I have a casting design and I try to find out in my foundry what kind of defects are likely or it is prone to certain defects. If there is a thin wall section, whether anything is there, whether there will be shrinkage in the heavy area. So all these can be visually, it can be simulated and learns from the production feedback, which designs produce defect-free castings and which needed rework. So once a new casting design is made, gating and risering is made, normally what happens is in most of the foundries, the design and development people will hand over to production. And then production will struggle with a bad design. One important thing what we saw here is that even when the casting goes into production and the data is being utilized by AI, it keeps on refining so that the initial assumptions which we had taken during designing, whether it is proved in the regular production run, and what are the comments the AI will predict, there is a good experience which can be utilized to capture the knowledge and apply it to the design, gating and risering, which casting, design, gating and risering are one of the biggest source of casting defects. Now, based on that, we have seen that shrinkage allowance or draft angle selection, machining allowances, parting line optimization, core print validation. These are the key things when the casting is being designed or when we're putting a new design in place. All these things requires to be finalized. And this is one of the areas where the lot of expertise is required. One important point Agentic AI remembers is that all the standards and codes which are used in Foundry, for example, let us say AFS pattern makers allowances, or let us say dimensional tolerances as per ISO 8062, a particular CT brand, all these are already known by the Agentic AI. So if I need not teach all those things, or I need not refer all these things every time. So if I prompt my tool saying that let us have a casting design, which is, let us say, applicable to, let us say, CT6 for my foundry, I will have a casting design. If the same casting is made by some other foundry who want, let us say, CT10, then it applies the different tolerances. And it also remembers that what tolerances I applied for which kind of pattern, which kind of casting, what are the alloys. So many of these things, these knowledges are already captured and applied. Similarly, for parting line optimization, core print validation, a lot of defects are related to core prints not correctly made, or we see defects like sandfall or something. So these issues are already handled in the pattern design stage. So when we apply, and one important point which I wanted to tell you is, like all AI, it gives a recommendation. Now, whether that recommendation is valid or not, or whether you want to apply it or not, That depends on us. The amount of work which is required to arrive at the recommendation we save. And once we agree with a recommendation, and this process is repeated for many occasions, AI also again remembers that which kind of recommendations were first time pass, or finally the designer, he wanted some, he made some changes in that. So it remembers what are the things we did. Similarly, if when we do the operation first time, for example, I am making a AI tool for a given foundry. So what are the facilities available? Which kind of molding machine is available? Which kind of fettling is available? Which kind of furnaces are available? These are all pre-fed, so that it does not give us outlandish solutions. Now, once the pattern is made, see, converting a component into a casting drawing, from a casting drawing into a die drawing, into a pattern drawing, and from pattern drawing, having the feeding systems and putting everything in place. For a new casting, this whole thing, if we have fed the information, can be done in 6 to 7 minutes, which is a big amount of time which can be crunched, and we will be much nearer to the solution. Now, once we have approved the design or the pattern drawing, gating, rising, and all those things, once the approval is done, we need to machine the patterns, or we need to machine the die, we need to machine the core box. So if we have an in-house facility, it is good. If we don't have an in-house facility, it can be done outside. But I can automate the G code and M code generation, which is required to optimize the pattern machining, so that I can know what are the G codes required, what are the M codes required, what are the toolings required, how much cycle time it should come. So practically, if I have a machine shop, I can know how much it can be optimized, how much it should be done. And if I am sending it out for some pattern shop or somewhere, then I will know that what is the amount of charges we can do. It gives us a negotiating information. So it helps us to cutting parameters, optimize toolpath generation, adaptive G code, programming or time reduction. So all kind of complex operations it can handle. Now, we all know that melting, holding, heat treatment furnaces are the biggest energy guzzlers in any kind of foundry. So when I do the planning, I need to know what kind of energy will be consumed. We take help of AI to ensure that the furnaces must run on optimum capacity. The occasions where the lining gets hot, then the lining gets cold, then again you have to heat it, again you have to cold it. And specifically in copper and brass industry, where you need to take multiple wash heats, you can avoid all that. Refractory wear, all these are interlinked. And all this is also interlinked with planning. So AI, it keeps on understanding how the energy is being used, and we can ask the tool what should be done to reduce the consumption of power, and what are the options available. So we can do a lot of if and what if combinations and see and ask the AI tool to recommend what kind of planning we should be able to do so that our energy is on the lower side. This is one of the areas, all the foundries which are facing casting defects. So normally, again, it depends on the complexity of the casting, what kind of equipment we have. But there will be castings which have got high rejections, maybe up to 20-25%. There could be rejections which are normally in the range of 5 to 7%. So, what is the process intelligence and the real time optimization required to get a good casting? For example, if I am having a casting which can tolerate, let us say, 3% moisture, there are, let us say, some castings which can allow up to 4% moisture, or maybe you get their GCS is low or GCS is high. Now, the sand mix data, if I want to make a GCS on the lower side, the sand mix may be different. If I want a GCS very, very high, around 1400, let us say, then the GCS will be different. And now when we do the molding, can I get a recommendation that what needs to be used? Because everything has got a cost. Foundry consumables are one of the biggest after the metal part. It is a big cost. Similarly for composition, similarly for all the other parameters. For example, here one example I can give is in the new cars which are coming, all the parameters related to the seat changes as soon as one person enters. So it can recognize that which parameters are comfortable or suitable to the driver. A similar analogy can be given for all the mixers, all the sand parameters, the pouring time, the distance between the furnace and the pouring area. So all this layout and all that can be pre-fed to the tool, and then it can identify what are the best options available. So this AI correlation engine, what we see, it correlates. And these are very, very small fraction of a time it can understand. So, and then it can recommend that this needs to be done. So there are so many defect types given: shrinkage, sand inclusions, cold shut, Mishran, gas porosity. I think shrinkage and sand inclusions are the maximum rejections which are being faced by the foundries. So how to handle that? It gives a risk score. We can have alarms, foresight alarms. For example, it is very difficult to note, for example, that given in a given heat, the sulfur content is regularly going up. I do not know how many people they will be analyzing a data to see what is the sulfur run, whether the sulfur is going up or sulfur is going down, whether hardness range, what we are getting in the casting, in the same type of castings are different. Is there any correlation with the operator? Is there any particular operator who always has a low rejection? Is there any particular operator who always has a high rejection? The standard reply what we get in Foundry is that we have not changed anything. The rejection has gone up or the rejection has gone down. So there are many areas which we understand. Many times we don't understand, and many times simply we don't have the time to make or teach to the people. So these areas can be handled very, very effectively. Now we are talking about consumable control. So there are various ferroalloys, inoculants, optimal charge mixing, which we call least cost charge mix, then binder and sand additives. So adding more additives for a bentocol, if a bentonite, if I am adding, if more I add, there is a problem, less I add, there is a problem. So it requires optimization. Similarly for charge mix, and with the kind of fluctuations what we are seeing in the market as compared for big iron prices or the copper scrap or ferroalloys or inoculants, these directly affect the consumable costs. And any foundry which is wishing to have the optimum consumable control system, they can use this data, and this data can be linked, all this data can be linked to the final casting properties. Now we talk about preventive and predictive maintenance. One change what we have seen is that earlier we had something called a time-based maintenance or a condition-based maintenance. Now there is a new term which is called a prescriptive maintenance, which is being agentic AI helps you. And we in Foundry, we know that timely maintenance is very, very critical. And what happens in Foundry is that any molding machine or any kind of intensive mixer, furnaces and all that, we have a time-based system. But we may be still overdoing or underdoing. What agentic AI does is, it monitors the life of particular critical spares, or it identifies that which are the parts which are likely to fail, which are showing high temperature or a high noise. So this particular monitoring, it can predict that this machine is going to fail on this time, and to prevent that failure for a particular machine, this should be done or these actions should be taken. So what happens is, let us say I have got two short blasting same machines in the foundry. So both may not have the same maintenance predictive prescribed maintenance. Both may not have, if the both are showing different characteristics. So these are the four machines which are given on the right: induction furnace or cupola or molding machines, short blasting machines, and DG sets or compressor. These are more prone to failures. So all these monitoring, like current, motor blade repair, jolt, squeeze pressure, the pin diameters, oil changes, oil quality, blocking of the cooling coils in the induction furnace. All these can be we can ensure that with a prescriptive agentic AI, this can be addressed. Now we go to something called AI-driven production planning and capacity utilization. So all foundrymen are aware that keeping the foundry running at full capacity will help us in reducing costs like electricity, power, consumable cost, and to ensure a proper rhythm of production. Things like refractory failure. Now, This production planning, again, in ductile iron foundry, it can be, for example, if I am grade from 400 bar 12, I am going to, let us say, 500 bar 7. There may be some changes required. Similarly, when I am going from in copper grade 863 to, let us say, CW 713. So these planning help us to eliminate or reduce setup times. If I am regularly changing a pattern many times, I will be wasting my time. If I don't change a pattern, then what happens? So there are various options. And if your foundry has a machine shop to machine the castings, then the primary function of the foundry becomes to feed the machine shop. And we do not need WIP in the process. So when we are doing an exercise for one foundry, they told us that the casting dispatch time and the pouring time, there should not be more than 8 hours gap. That is to eliminate the WIP to ensure single piece flow. Then I can also get a recommendation when if the foundry is already existing, what best can be done to alter the layout. If I'm going to make a new foundry, what are the best options available to reduce the material flow? How to ensure the capacity of the bottleneck machines is full. So all these options can come from production planning and capacity utilization model. In foundry, hardly anything happens as per the plan. So if I have, let us say on day one, I have planned certain castings, and I actually what happens may be a little bit different because either some rejection has happened or not happened. So you either you have produced less than casting.
To reduce heat changes and environmental.
Sorry.
Yeah, you can continue. I think there is a crosstalk.
Yeah. So WIP reduction, flow optimization across foundry operations, real-time WIP visibility, bottleneck identification, inter-process synchronization, pull-based dispatch alignment. So all these, ideally, if the customer is giving me a dispatch plan, I need to work back to the foundry. So there has to be a pull system. So how to ensure that the pull system is best, that can be optimized. One important point what in Foundry, what I have observed is the costing, what we do, what we have given in the RFQ to the customer, what actually happens. And many of this is not very, very clear, or they are spread across so many departments that if I ask the question that who is responsible to ensure that we get better costing than what was given in the RFQ, then it will become very difficult. Who monitors it? Who does not monitor it? So when we did the AI driven costing, I can get a daily or a shift wise costing about how much the resources were used. And if you use AI driven costing, the RFQs, which normally foundries take a lot of time, or to eliminate the guesswork, or eliminate the assumptions, or to validate the assumptions. So we are at a better footing. So code generation, material process castings, drawing ingestion, overhead and scrap allowance, this can be addressed. This is one of the areas where we are saying office documentation, office automation, export documentation, knowledge retention. Now with the so many HSN codes coming, various permutation and combinations required for freight optimization. Then procurement and supplier management. When we were at the consumables module, whether the consumable is available, not available. So all the things what we do as a company, as a foundry, with the customer, communication with the customer or communication with the supplier, this whole thing can be automated. So that the entire chain of getting a customer order, raising a PO, getting the supplier invoice, getting the customer invoice, cash flow management, all these activity can be automated. Ideally, you don't need anybody in the office. You need one person whom we call human in the loop, who has to certify. And once he keeps on certifying, the AI tool picks up that this kind of behavior is acceptable, this kind of behavior is not acceptable, or in case of emergencies, this should be done. So we are addressing office automation, we are export documentation where mistakes are very, very expensive. And knowledge retention. Now, knowledge retention is one of the biggest issues in Foundry what we are facing now. That the knowledge we find as soon as the person has some knowledge, he will move. So to prevent the knowledge from going out, or even if it is going out, it cannot be immediately used, So there are so many systems which can help us in doing so. These are some of the examples which people have done already. While foundries are not going big way, at least in AI, there are certain foundries who have got good results. So these are some of the examples where they have done, where they have reduced the casting, they have reduced the inspection time. Inspection time and the criteria used for accepting or rejecting a casting. See, most of the times in Foundry, we ourselves are not very consistent in which is acceptable blowhole, which is not acceptable blowhole, what are the guidelines. And the person who has got the knowledge of accepting or rejecting a casting, who knows all the criteria, is not doing the inspection. The inspection is being done by some inspector who has just joined, or maybe 1 year old or 2 year old. The average retention of an inspector is becoming very, very less. So there are certain companies who have already implemented, and we are also helping some companies to implement. So normally what happens is every foundry has got a different pain point. And the objective of implementing agentic AI is to reduce the anxiety, reduce the pain point, and make it smooth. Now, the difference between a normal automation is that even if you're doing a wrong activity, it gets done fast. That's the only difference. And with agentic AI, I can reason with the tool can recommend, I can argue with the tool, I can know what is the logic behind the tool and ensure that it is implemented. So for small projects, we have implemented projects within 3 weeks. We have implemented projects which are within 3 weeks. And gradually, as the tool becomes more mature, the human intervention keeps on becoming less. And the people in the foundry are free to use their minds to grow the business, to meet the customers. There are so many other things rather than spending 90% of your time bothering about the whether the production has come, whether there is a breakdown, whether there is a raw material scarcity. All these can be the amount of headaches can be reduced. So we discussed Agentic AI is the production ready technology being used in the foundries. Already being used. Already there are certain companies. Apart from foundries, if you go, there are so many other people, other companies who have started implementing it. Start with the old one painful PM, ROI, whether whatever you are investing, whether it comes back or not. Experience is required. Whatever the AI is saying, somebody has to certify, but you have enough time in your hand to certify. And that also you have to do it 2 or 3 times or 4 times. So that their knowledge becomes the foundation of AI. ROI has come so far. Process data is the biggest asset. So it says data is the new oil. So how this data, which is generating shift by shift continuously across many machines, many people, we can identify which are resources are capable resources, which resources are not capable resources. And it is going to be a competitive advantage. So this is, we have tried to explain in a very brief. We are open to any kind of questions. And if there is a application in your mind or what the production data we currently capture, supervisor knowledge and decision making challenges, there are so many challenges in that. Implementation cost, data change management. So many of these, every foundry has his own issue. So if you have got any questions, me and Aditya will be able to address here. Otherwise, we can discuss on mail or communication. Thank you.
Yeah, good afternoon, Aditya and Abijit. Can I come in?
Yes, please.
Yeah, I'm Chandrasekhar here, Secretary of IAF Bangalore chapter. See, companies like ours are all small scale industries or micro industries. This presentation was quite informative for people like us who see a challenge in recruiting people, retaining them. Nobody wants to be in the industry that we are into, particularly the Gen Next. But having said that, we find it more challenging to identify who could help us in identifying the appropriate tool for our functions. Okay, first of all, we are not just traditional, we are before traditional in some cases. So first we have to get used to this chat GPT, then AI, which we are still, except for those words, we don't know much about it because we are busy with our own survival demands. Now coming next to agentic AI, yes, if we have to go for this, so we don't know whom to depend upon. Who could be a agency who could validate that we are in the safe, we are the safe agency. So can you just throw some light on how you could pitch in and help us out in that, in case we would like to go for that?
See, there will be so many people outside in the market who are giving consultancy in AI. But what happens is, what we found is it is very difficult to teach Foundry to AI people. It is equally difficult to teach AI techniques to a Foundry person. Both are. So what we did is that I have got about 4 decades of experience, and you need a expertise to identify whether the AI tool what you have implemented is giving you the result or it is not giving you the result. AI needs to be verified. The questions you ask it and it gives you some reply needs to be verified. So there is a concept called a human in the loop. So human in the loop, what it does is that whatever solutions the AI is recommending, you have the authority to accept or reject. So for example, if I implement AI tool in your Foundry, there will be one person in your Foundry who will validate that whatever it is saying, it makes sense, or I will try and then I will take a call. The ultimate decision is of the human, and we can help in implementing.
So I think the place to start is to first identify the areas of improvement and also the problem statement. See, the thing is, AI by itself is a solution. Now, every problem is very different. So
Yes.
if we think from the solution perspective that we have AI and we want to use it, then maybe, what happens is it kind of, you are forcefully adding that solution. So I think the starting point is to identify what areas of improvements do you have. The best places to look for this is what processes are repeated very frequently and done by humans on a very regular basis. Those are like the first thing that we can solve using AI. So if you already know, you are very closely running your businesses and you already know, okay, this thing happens to me every day. I have one person specifically dedicated for this who is doing this on a daily basis and telling me these results. And because that person has been working for some time or, they have gotten good at it. So they are, doing it very well. So, but the thing is, what happens is because you're spending a lot of time in doing it, how much time are we actually spending in looking at the final outcome? Because that is the most important thing. If your production is going to plan, not going to plan, how that is happening. So I think the place to start is by observing and first identifying the areas of improvement and then seeing how AI can help you solve it.
Yeah, that's right. Actually, what we find is that most of the people, all the foundries, we senior people or middle management people, or everybody is busy in firefighting and very,
Yes.
very less time for improvements. So what results into the firefighting? That is the area where AI can help. So the question to the foundries, which I ask is, which are the areas where you are spending most of your time firefighting, and what makes it difficult for us to get organized? Once we discuss, and everybody has got a different pain point. Some people have got issues in casting design. Some people have got rejection issues. Some people have a high consumables consumption issue, cost not setting, margin in the negative. People, if I ask, for example, how much, while you are doing the planning, which are the parts we should not miss, which are the parts we can afford to miss, how much of the capacity you are using. So the idea is to move all the critical stuff into improvement mode. And to get those people into improvement mode, we need AI to ensure that all the issues related to the firefighting does not arise at the first place.
One part I would also like to add is that what AI has done is that it has democratized software as well. Now, earlier, what used to happen that if you went to the market for solutions like these, like, you went to SAP or you went to some other provider, they would tell you have to buy this entire tool and you have to adapt your systems to how our system works. So now if your
Yes.
document is in a specific format, you have to make it in our format so that our software can process it. But what AI has done, the superpower it has, it can adapt to your system. So you're not, completely plugging out your system. You're not replacing your software. You don't have any licensing cost. Like every 1 year or 2 years, the contract will run and then you have to pay a huge amount of money again. So that has also become a big factor. Now, if you have some software and you need only one small part of it, you can only build that small part and you can only pay for that small part.
அதாவது இப்ப ஒரு இதை பில்ட் பண்ணும்போது பாத்தீங்கன்னா அங்க
I
கொஞ்சம் இங்க
think
கொஞ்சம்
someone had a question here.
சிஸ்டமேட்டிக்கா
Mr.
வந்து
Sridhar,
டெவலப்
Mr. Sridhar had a
நம்மளோடது
question.
என்னன்னா இப்ப நான் போன தடவை எடுத்ததே வந்து ஃபர்ஸ்ட் சேல்ஸ் தான் எடுத்தேன்.
Hey, somebody is talking and they are not.
ஒன்னொன்னு வந்து அதுல கொஞ்சம் அவருக்கு பிரச்சனை இருக்குன்னா இப்ப
Yeah, I think the host can mute them.
அது மெஷர் பண்ண ஆரம்பிச்சிட்டோம். இந்த பெண்டிங் ஆர்டர் வந்து
Yeah, thank you.
Yeah, I think you have
Sure.
hit the nail on the head. So that is a correct point. What you are telling is that we need not alter our systems to suit their software. So that is an important point what you have raised, and that is why, for example, if I say reduce rejections, we'll have different solutions for different foundries, different AI modules. So it can be customized to our working.
I have a question here.
Yeah.
You mentioned that you help in implementation. Is it on the advisory side or on the tech side also?
It's on the tech side also.
Fantastic. So probably we'll reach out to you. We have some thoughts that we'd like to discuss with you.
Yeah, my question was, the AI, you said AI gets updated on its own. Means what? Again, manual update is required. Input should be manual, or how it is?
So there can be
See,
both.
yes.
Okay. I'll take this
Go on,
question.
Aditya. Go on.
Yeah, I'll take this question. So yeah, it can be both. So for example, let's say your system generates a report, and that report can be scheduled. Now, if that report can be scheduled to be generated, let's say it's maybe even live data is you have sources to get live data, and also you have systems that can generate reports on an hourly basis, daily basis. The AI can consume that input and again process the output. So it can be either manual, it can be automated. Even in automation, it can be at different levels. Maybe it's an hourly thing, a daily thing, or it can even get live data as well. It depends completely on the source about how it is generating the data.
Okay, so it what I understand is it can be used as a directory for different problems. We can also look for different solutions.
It's completely open. I mean, the possibilities with AI is like infinite at this point. Yeah, I think someone from Magna Electrocasting Limited. What are the different AI modules available? Can you maybe add to that, like specifically what kind of modules that you're referring to? From a solution perspective, you have multiple modules. I mean, I think whatever Abhijit sir covered in this presentation is all covered by AI. Yeah, Mr. Krishna.
Yeah, good afternoon, sir. This is Sergio
Good
from Bangalore. Yeah. Regarding the costing, how can you compare with the regular cost and what is the cost and what is the costing what Abhijit sir is told no regarding the cost? How we can compare in AI?
SAP ERP component.
It is one, and SAP, what you are doing is SAP cost and in the AI cost.
See, I think the best way to look at the cost as, if I understood the question correctly, is asking if like how the cost compares between the AI solution and traditional solution. Is that the question?
Yes, yes, yes.
Yeah, I think there's different ways to look at it. I mean, the cost of AI should be looked at in comparison to the value it is generating. Now, SAP and other tools are industry standards. They have certain modules that are, have been built over time and everything. But then there are also they're very general models, so they may or may not completely suit your needs. So they usually charge by the license, and it varies a lot depending on how big the contract is, for how many years you're taking, how many licenses you're taking. So I think the commercials depend from uh, every company to company. The cost of AI, I think it depends completely because at least the way we do it is that we build a custom solutions for everyone. So it completely depends upon the scope of the requirement and how much you're getting to get developed. So I mean, it's a hard question to answer. It's very specific to every case.
Okay.
Maybe on a case basis we can maybe if we connect offline, we can maybe see what the value is.
Thank you. One more question from my side. How will AI will help to make the design of pattern and core boxes?
Yep. See, the design, for example, if the customer is asking some casting which is machined or maybe in the condition what he wants. Now, when that casting comes to us, when that component requirement comes to us, what do? We add allowances, we add parting line, we add how we are going to pour it based on whatever machines we have, the molding machine what we have, and what are the tolerances which are applicable, whether we are doing the machining or he is doing the machining, which are the points where he is going to hold the casting, but the castings. All this information is, and plus the standards, for example, pattern maker allowances or some AFS or BCIRA standards which are applicable. All these are pre-fed in the AI and this can be directly implemented. So what it will do is it will give you a casting design or it will give you a die design and you have to certify that this is what you wanted. And this will happen in minutes.
But each and every model have to feed or general have to feed?
No, you have to make one module from that agentic module. There you can give the castings, it will design and give you back.
Okay.
There was one question regarding inspection, I think, regarded to core inspection. So yes, the core inspection or mold inspection or casting inspection, any kind of inspection can be AI enabled to eliminate the judgment part. Because what happens, there in everybody knows in Foundry, every inspector has got a bias. Either it is a bias for accepting castings or bias for rejecting casting. So this can be AI enabled so that you have a consistent system of accepting a core or a casting or a mold. It can be done.
Okay.
So this means the AI models are already inbuilt history of problem and solutions.
It has access to the entire literature on castings, which is maybe not possible. For example, I say I got 35 years of experience. It means I have used 35 years in reading something or doing something on the shop or gradually finding out, trying my own solutions. And when the AI is being built, it has got access to all these tools. That is what I was saying. That inspection has to be done as per customer standard number this. So if we tell him, so if it is a proprietary material, we have to inform it or upload the file. But if it is generic material, for example, let us say you check it against ISO 8062 or you check it 2768 or some specific standard which is already published. So that information is already pre-fed into the system.
A couple of days ago, what we did was we were just doing an experiment where we gave the AI a picture of a defective part and we did not give it any other context, only the picture. And only looking at the picture, we asked it, what are the defects that you can possibly think in this part? And it gave us an entire list of all the possible things that could have happened. So all of these models that we have are already trained on so much knowledge that it can look at something and without any other additional context, it can give you a list of all the possible things that could have happened. And from that, if you start specifying more things, okay, you know what, I built it under this temperature, this was my material, this is what I did. As you become more specific, the more pointed guidance or knowledge it can give you. But by baseline, it already has a lot of knowledge to begin with.
That is good.
but more appropriate.
See, in this slide, if you read the bottom, this thing, a traditional, it says, it's like a recipe that never, agentic AI is like an experienced Foundry supervisors who watches your entire operation, understands what is good output looks like, spots the warning sign before they become defects, and takes corrective action, all without waiting to be told step by step what to do. It works across shifts 24 hours a day without fatigue. It's like a supervisor who comes and never leaves your Foundry. So over the period of time, he gains experience, he gains the foresight, he gains the knowledge, and which can be crunched. You need not wait for 30-40 years. The number of experiences and a lot of people can enrich that tool. So, and it tells you, and it tells that what was the final result. Did the rejection come down? And what are the things? People who are from quality, they will understand. For example, if I want to do a orthogonal array test, let us say I want to do a L9 test orthogonal for sandwich GCS related to, let us say, bentonite content, number of dead clay, active clay. If I want to do a orthogonal array, it helps us to do a orthogonal array and interpret the results.
I think someone asked a very important question here about how data input can become outdated and error prone. So that is very important because obviously, in lack of better words, is garbage in, garbage out kind of a scenario. So it is very important that the data is of high quality, it is very accurate. And that is something that AI can help as well. So if you have some sort of a validation layer where it tells you about how the data that is coming in, about whether it looks right or it looks wrong, and you can always build better processes or systems to generate that data that can be given to the AI. So if there are manual processes in your companies, so that needs to get upgraded, about how that data can be collected more in an automated fashion. So all of those things, the entire pipeline going into the AI also gets upgraded in the process of, in this process of AI transformation. So yes, it is very important that the data is clean. It is the latest data. It is clean data. So that's a very important part.
In this slide, these last two lines gives us our contact. So if anybody has a query or they are able to, they need some questions to be answered or something, you can go to this website. We are specialists in applying AI into metal casting units. And these questions, you can go to the website, you can register there, or you can send this query here, and we can reply to you offline.
Thank you for having us. It was a great honor talking to all of you.
Thank you.
Thank you.
Much appreciate this, sir.
Thank you.
Mr. Padmanabhan, are you there?
Yeah.
Yeah,
Thank you, sir.
Chandrasekhar also here. Yeah.
Thanks for this session. Sir, Chandrasekhar.
Yeah, you have anything to say, Padmanabhan sir?
No.
Okay.
Already
Sir,
discussed.
good evening. Good evening, all of you. And once again, today's topic, implementation of agentic AI in Foundry operation. both by Mr. Abijit Bhattacharya and Aditya Bhattacharya, was very informative, and it highlights the importance of upskilling ourselves in emerging technologies for our own sustenance and growth, particularly our foundry industry. And it will also add to your better profits. And the takeaways of this today's session, what I could get, probably the other 48 guests and members who attended, some of them I would like to highlight here. There's a massive potential benefits by using Agentic AI tool, which you rightly said is a 24/7 supervisor. It helps in energy optimization. This is another important requirement in today's business. The process intelligence, it supports recommendation of predictive maintenance. It learns continuously and recommends. It remembers standards, which normally we take time to retrieve it. It also remembers tolerances applicable for various, whether it is patterns or castings or alloys. Parallelly, also it contributes to higher productivity and less rejection. Shift-wise costing is one good thing that I could see will benefit the foundry industry, because the moment it is crossing a red line, you are able to audit yourself and review where you're going wrong. It also supports office automation and the molding section, mold inspection, core inspection. And when you said it retains knowledge retention, that is also a very important aspect of agentic AI, because we end up losing out people once everything has got streamlined. And again, the owner has to restart it. And the final thing that I could get was AI can adapt to our existing system and also appropriately recommend. So with all these features, I think the entire foundry fraternity will be, interested to again reconnect with you people online. And I'm sure it will benefit all the people here. And on behalf of the Institute of Indian Foundrymen, Southern Region, Bangalore chapter, National Center for Skill Development members, I thank both of you for an insightful session today. Thanks all of you. Thanks to the speakers, thanks to the organizers, and thanks to all the members and guests who have attended today. Thank you so much.
Thank you.
So with this, we can now wind up if there's nothing else from the organizers to
Yeah.
speak.
Thank you so much, Mr.
Okay,
Bhattacharya.
thank you so much. Thanks all of you. Have a nice day. Bye.